Welcome to Real Civil YouTube channel. In this video, I am going to explain you how can we design an axially loaded column, and we will also see the clauses from IS 456 related to the design of RC column, axial loaded RC column. So let's start. So this is our problem. Design a RC column of size 450 by 600 mm subjected to axial load of 2000 kilonewton under service load or service condition. The unsupported length of the column is 3 meter. Use M20 and Fe415 steel. Okay, so the important points are, or I can say there are two types of design questions can be formed. The first, in which the cross section area is given and you have to find the area of steel, and the second question can be formed where both cross section area as well as area of steel, both the things you need to design. So this is the first type of question where size is given, we need to determine the AST. In second video we'll see both. So let's see the important points. Size of the section is already given. This is the service load. Unsupported length is 3 meter and grade of concrete EM20 and Fe415 is given. So let's start to solve the problem. The very first step is the check for short or long column. So we have to check here our column is long or short. So for that the condition is given in IS 456. Here you can see short and slender compression member. A compression member may be considered as a short when both the slenderness ratio Lex upon D, Ley upon B are less than 12. So here if I draw, so this is our cross section and this side is 600 mm, whereas this side is 450 mm. So let's check lambda, that is L upon B ratio. Length is given 3000, that is height of the column, length of the column 3000 divided by B. Here we have to consider the least lateral dimension. Out of 450 by 600 mm, 450 is least. So if we divide 3000 by 450, we will get 6.67. That ratio is less than 12. So we can say our column is short column. For short column, the condition is your lambda or slenderness ratio should lie between 3 to 12. So this is okay as per the clause. Or we can say this is a short column, so we have to design it as a short column. Next, very important, we have to check for the minimum eccentricity check. For minimum eccentricity check, we have to go to clause number 25.4 of IS code. So here this is the clause. Minimum eccentricity. All the columns shall be designed for the minimum eccentricity equal to unsupported length of column divided by 500 plus lateral dimension divided by 30 subjected to minimum of 20 mm. So in simple language, first we will check the minimum eccentricity x direction. So the formula is L unsupported divided by 500 plus B divided by 30. So unsupported length of the column is 3000, that is 3 meter divided by 500 plus, as we are checking the eccentricity in x direction, the dimension is 450 divided by 30. So this is the formula L unsupported divided by 500 plus B by 30. So the answer comes 21 mm or 20 mm. So we have to select the maximum one. So minimum eccentricity in x direction is 21 mm. Okay. Now very important, this is the minimum eccentricity, but we have to ensure that this minimum eccentricity is less than 0.05 times the lateral dimension. Okay, so this clause is given in 39.3. I will show. So here you can see the member shall be designed by considering the assumption given in 39.1 and the minimum eccentricity. So we have just seen the minimum eccentricity in x direction. When the minimum eccentricity as per 25.4 does not exceed 0.05 times the lateral dimension, then you can use the following formula. So we have to check that minimum eccentricity, that is in our case it is 21 mm, it is less than 5% of that dimension, that is 0.05 b. So 0.05 into that dimension is 450, so the value is 22.5. So we can say 22.5 is less than 21. That means we can design the column with minimum eccentricity. Otherwise, we have to consider the eccentricity and moments. Similarly, we have to do it for y direction. So here you can see minimum eccentricity y direction, unsupported length divided by 500 plus, now here only change will be here y direction, that is dimension perpendicular to the y, that is d, and here we have considered eccentricity in x direction due to x direction perpendicular dimension to the x, that is we have considered this as a b and this as a d. So this is y axis and this is x axis, this is our d and this is our b. So x direction we have to consider perpendicular, that is b, and for y direction we have to consider the perpendicular, that is d. I hope the concept is clear. So formula is same, only change is here it will be d. So if you put the values in d, that is d is 600, our answer is 26 or 20 mm. So 20 mm is must, that is the minimum, or if there is extra eccentricity we have to consider that. Okay, again same, we have to check the minimum eccentricity is less than 0.05 d. Okay, for y direction it will be the perpendicular dimension, that is d, which is 600. So that comes out to be 30. So 26 is less than 30. Okay. So if it is okay, then code says you can use the following formula for the design. So I have written this formula. PU is equal to 0.4 FCK AG minus ASC plus 0.67 FY ASC. So if you see in the code, here it is AC. So area of concrete is nothing but gross area minus area of steel in the concrete. So we have just split up that quantity. So you can see the load given is 2000 kilonewton, but that load is service load. Hence we have to multiply by 1.5. That means ultimate load we have to consider, or factored load we have to consider. 0.4 as it is. FCK grade of concrete is 20. Gross area means B into D, 450 by 600 minus ASC. This is what we have to calculate. Plus 0.67. FY is given 415 ASC, which we have to calculate. So only one unknown is there. If you solve this, we will get the area of steel 3110.5 mm square. Okay, so here we have to check that whatever steel we got here is greater than the minimum. So if you come to the page number 61, or it is 48, the cross-sectional area of longitudinal reinforcement shall not be less than 0.8% nor more than 6% of the gross cross-sectional area of the column. So here 0.8 is the minimum, 0.8% into gross cross-sectional area, that is B into D. So this is 2160 mm square, which is our steel is greater than that. So that check is also okay. So we have to convert, or we have to determine the number of bars to fulfill this area. So I have provided 4 bars of 20 mm and 4 bars of 25 mm. Together the AST provided will become 3220.12 mm square, which is greater than AST minimum and which is also greater than AST required. So here you can see the AST required is 3110 and we are providing 3220. Okay. Now next is the clause related to the lateral ties. That means horizontal steel, lateral steel. There are two things. First thing is about deciding the diameter of the lateral ties, and second thing is deciding the spacing. To decide the diameter, there are two conditions. First one, minimum 6 mm, or whatever diameter you have used as a longitudinal bar, means maximum longitudinal bar diameter divided by 4. So here you can see we have used 20 mm and 25 mm. That means maximum is 25. So 25 divided by 4, which comes out to be 6.25, and here 6 mm. That means we have to provide greater than 6.25 or equal to. So in market, we cannot get 6.25 mm bar. So we have to use 8 mm bar, which is available in the market. So first thing is clear. Now rule for the spacing. So there are three conditions for the spacing. First one is the least lateral dimension, 450. Our column is 450 by 600. So 450 is least lateral dimension. Second condition is minimum 300 or 16 phi, where phi is the minimum longitudinal diameter. So as I told you, this phi is 20 because we have used two diameters, 25 and 20. So minimum is 20 into 16, that is 320. So out of these three, we have to provide the minimum. So minimum will be 300 center to center and 8 mm bar diameter. So let's see the last, that is the cross section. So this is our column. This is 600 by 450. We can provide minimum 40 mm cover. These are our bars, longitudinal bars of 25 mm, and these are the 20 mm bars, and this is the stirrup. Okay. Another thing, we have to make sure that these bars, the spacing between these bars should not be greater than 300 mm. Okay. That's why we have provided 3 bars here, 3 bars here, 3 bars here, 3 bars here. I hope the concept is clear. In the second video, we will see that dimensions are also not given in the problem. We have to assume the dimensions. We have to find the dimension as well as the area of steel. So let's see these things in our next video. Thank you. Please like, share, subscribe the channel. Thank you so much.